In Objective 3, we're going to start writing the equation of given polynomial functions from specific information. In examples 1 and 2, we're not given all the information we need because we need to know all of the x-intercepts plus another point. Well, in example number 1, we don't know all the information. We know all of the x-intercepts or all of the zeros, but we don't have that one other point, whether it be the y-intercept or any other point on the graph, that locks the graph into place. So, for example number 1, the best we can do is write an equation that could represent this graph. So here's what we know. We know that one of the x-intercepts is -1, and it's a pass-through. So the only way that can possibly happen is if the factor was x plus 1, and the power was simply 1. Now moving on to the next one. The x-intercept is +4, which means it came from a factor of x minus 4, and since it was a bounce graph, it didn't pass through, it bounced. That meant the power was squared. Now the last one is 5, which means it came from a factor of x minus 5, and it was to the first power. Now we've got most of this written, but the big question is, what could the a value be? We don't know what the a value is, because we don't have that other one point to lock the graph in place, but we could come up with an a that would work by looking at the leading term and the end behavior of the graph. We know this is a low-to-low graph, and we know the highest term would be x times x squared times another x would be x to the 4th power. So this is a quartic equation. Now, if the power is even, what does it take for the graph to go low to low? Well, you go back to that chart we made right here. I even have one. I use it as a little cheat sheet. Low to low with an even term of the power means my leading coefficient had to have been negative. So as long as I put any negative value right here for the a, I'd be all right. So I'm just going to put -2 and then x plus 1 times x minus 4 squared times x minus 5. So as long as this is negative, I'm good. Now, some of your questions on your homework ask you to do this. Let's do one more. Example number 2. We're going to go y equals a. Now, -2 is an x-intercept or a 0, and it bounces. So that means the factor had to have been x plus 2, and it had to have been squared. Now, here's another x-intercept at 0. Well, what kind of a factor produces 0 as a 0? X. And it's a pass-through. 1 is also a pass-through, so that means x minus 1 had to have been a factor. And 3 is also a pass-through, which meant x minus 3 had to have been a factor. So let's just take a quick look at the leading term, x squared times another x, x to the 3rd times another x, x to the 4th times another x would be x to the 5th. So this would be a 5th degree polynomial. So that's odd. And in order for it to go low to high, which is the end behavior, odd, low to high means the leading coefficient had to have been a positive number. So we just need to make sure that that's a positive number. Well, and instead of using 2, I'll use 3 for some reason. 3x plus 2 squared times x minus 1 times x minus 3. And as long as that's a positive number, that could have been the equation of this graph. For example 3, we're going to be able to get more specific, and we're going to be able to actually write the equation represented by this graph. Because not only do we know all the x-intercepts, but we know one additional point on the graph. That's all we need to know. All the x-intercepts and one additional graph in order to write the true equation of the function. So let's start with y equals a again, because the a value is going to be the last thing that we solve for. Let's look at the x-intercepts. If one of the x-intercepts is minus 2, negative 2, then that means the factor had to have been x plus 2. And since it was a pass-through, it has a multiplicity of 1. Now the next x-intercept is positive 3, so the factor had to have been x minus 3. And since it's a bounce, not a pass-through, it was a squared factor, multiplicity 2. And then the last one was 5, so that had to have come from x minus 5 with a multiplicity 1. Now here's where that other point comes into play. We know that when x equals 1, the y value is negative 120. So that's what we're going to do. We're going to plug in this known information. Y equals negative 120 when the x values are 1. So I'm just going to substitute 1 plus 2. 1 minus 3 squared and 1 minus 5. Now it's just a matter of start simplifying. Negative 120 equals the a value times 3, 1 plus 2. Now 1 minus 3 is negative 2, but negative 2 squared is positive 4. And then 1 minus 5 is negative 4. So negative 120 equals a times 3 times 4 is 12, and 12 times negative 4 is negative 48. So negative 120 equals negative 48a. Now to solve for a, just divide both sides by negative 48. And you get a equals negative 120 over negative 48. When you reduce it, it becomes positive, and it becomes 5 over 2. So that gives us the equation y equals 5 over 2, and then all the factors. X plus 2, x minus 3 quantity squared, and x minus 5. Now, if you want to check this, you can, because you can use the leading coefficient. The leading coefficient would be x times another x squared, which makes x cubed, multiplied by another x, which would be x to the 4th. So that would be 5 halves x to the 4th power. That would be the leading term of this polynomial. Now, that means it has an even degree power and a positive leading coefficient. So, even degree powers with positive leading coefficients, the behavior is high to high. So does this graph start high and end high? And the answer is yes. So you can be pretty confident that you got this right. My fourth and final example. Sketch the polynomial function and write the equation given the following characteristics. It's a fifth degree function, so we already know it's odd, which passes through the x-axis at -4, 0. I've got that marked right here, x-intercept, -4, 0, and touches or is tangent to the x-axis at -1, 0, and at +5, 0. And the y-intercept is 0, -20. So we are capable of writing the true equation that represents the function, because not only do we know all the x-intercepts, we know one other point on the graph. Now, let's keep in mind a couple things. At -4, 0, it actually passes through. So I can start writing the equation. Y equals A times, at -4 it goes through. The factor would be x plus 4 in order for this to be -4. And since it passes through, the multiplicity is 1. But for the other two, they only touch the x-axis, or another way of saying it is they're tangent to the x-axis at -1. So the factor would have to be x plus 1, and it would have to be squared. And at 5, 0, the same thing. X minus 5 would have to be the factor for that to be +5. And since it's tangent to, or it bounces and only touches but doesn't pass through, it would have to be a squared factor. So that's our beginning point. Now the next thing we know is that y-intercept. Whenever x is 0, y has a value of -20, so we're going to use that as the last piece of the puzzle. My y value is -20 when the x value is 0. So if you mentally substituted a 0 for each one of these x's, this would be 4. Now 0 plus 1 is 1, but when you square it, it's still 1. 0 minus 5 is -5, but when you square it, it's +25. So now just start solving. -20 equals 4 times 25 is 100 times 1 is still 100. So 100a, if you divide both sides by 100, you should get an a value of -20 over 100, which reduces down to -1/5. So that puts the final equation at y equals -1/5 times x plus 4 times x plus 1 quantity squared times x minus 5 quantity squared. So that's the equation. Now the only thing we have to figure out is, how does this thing start? Does it start up here? Because we know what happens. It passes through here, it bounces here, and it bounces here. But where does it start? That's where the end behavior is going to help us. This is x times an x squared times another x squared. So that becomes x to the 5th. But the problem told us that from the very beginning it was a 5th degree function. And now we know the leading coefficient is -1/5. So the end behavior is negative and odd. So go back to hopefully your little cheat sheet you have somewhere. Negative, odd tells you high to low. So that should be what this graph does. if you follow all the right instructions. So we're going to start high up here. We're going to pass through, but we're going to turn around and bounce. Now, we're going to come through 0, -20, and at some point down here, we're going to turn around, but remember what we're going to do when we hit this 5. We're going to turn around and bounce again. So if you put all the characteristics of the problem together, this is what we do. And that's the graph.